So today lesson, we are talking about the geological processes of stream and floods. Yeah, actually in the calendar we have the groundwater first and then this lesson, but I rearrange the for better logic of the of the subject. Then we talk about the surface water first, and then we talk about the, the groundwater. And actually, this lesson is about the process of surface water, and we will learn about the water circle and the water distribution on the surface, and we will talk about the type of water flow on the surface of the earth and the activities of the stream, of the river, stream, and so on. And later on, we talk about the landform feature according to the activities of the stream. And finally, we talk a bit about the flood and flood control methods. Yeah. And for this lesson, I think we use reading material from the Open Geology textbook. And for the, I'm not sure, maybe the lecture for clip is not very clear. So mainly we use the reading materials and also use my presentation, my slides. Yeah. Okay. First, we talk about the water circle on the earth. So like the rock circle, the water circle, we talk about how the water traveling on in the lithosphere and on the also on the atmosphere. Yeah. And the water, this is a summary of circulation of the earth water supply, and it is very easy to imagine how the water circle is. It's from water on the surface, the evaporation occurs. Yeah, evaporation, then it will become cloud, and then from cloud rainfall or precipitation occur. And when the water access the surface, and one part of water run or flow on the surface, and one other part infiltrate into the soil and rock layers, into the ground. Yeah, and then and finally the rainfall equal to evaporation, transpiration. Transpiration is another process occur with the plant, with trees, through the transpiration. Also the water can go through the tree and to the air, to the atmosphere. Yeah, infiltration, it means the process water come into the ground, and run up here is a surface water. So the run up mean, today we talk about the run up. Yeah, the water run on the surface. It can be seed flow, or it can be the channel flows. Yeah, sorry, I think the mistake here, this is another process. Yeah, evaporation is separated from other process like precipitation, infiltration, runoffs, and transpiration. And how the water distribute on the earth? It can be on the surface of the earth. We call it the surface water, and it can be groundwater. Yeah, and actually, I forgot to put in the amount of different type water. Actually, the groundwater occupy very large volume in the total of the fresh water. Yeah, we have the water on the earth including the water in ocean, water underground, water on the surface in river, lake, and so on. And for the fresh water, the salty water mainly in ocean, yeah, and fresh water mainly it can be on the surface, it can be the groundwater, and groundwater play or occupy very large volume. Yeah, but yeah, we talk about the surface water first. The water maybe on the surface in stream or river or lake or pond or any other bodies of water on the surface. And the surface water, the surface runoff, or we call it overland flow, is a flow of water occurring on the ground surface when except rainwater, storm water, meltwater. Yeah, in the cold region we have a meltwater, or the other source can no longer sufficient rapidly infiltrate in the soil. So because it's not the soil cannot absorb all the rainwater, then one part of water run on the surface, and the streams that carry water during wet season or that after the rainfall are termed intermittent. Yeah, sometimes we have a different stream. Some stream we have a flow permanently, yeah, all the year, but some other stream that occur, the flow occur only in the wet season, or that only very short time during and after the rainfall, and after that the stream can be dry. Yeah, so we call it the intermittent. Yeah, this is to distinguish the difference between intermittent and the permanent flow or stream. We have the term stream is the geological terminology used for any flow of water on the surface, like it can be stream, spring, or river. And here another term, we have a drainage basin. And let's imagine here we have this system of different river or different stream here, but we have the drainage basin is an area of land that capture precipitation, that means the rainfalls, yeah, and contribute the runoff to a stream or stream segment. And here, first of all, the boundary, the red boundary here is the boundary of one basin set drainage basin, because the final here is the one stream, the main stream. It contribute by some other segment of stream, smaller stream. Yeah, we have a small spring and run to the larger stream, and from the larger stream can be run to rivers. Yeah, and the drainage basin is the basic unit of division of the landscape, and also known as the catchment or watershed. Yeah, we may use three terminologies interchangeably, yeah, with the same meaning. Yeah, that means the area of land that capture precipitation for one major stream. Okay, and talking about the runoff, the runoff may be related to some factor. Yeah, it can be related to the relief, to the surface of infiltration, maybe to the trees, yeah, cover, and to the surface storage. Yeah, we have here the different term. The relief is a difference between the elevation between the highest and the lowest point within an areas of interest. Yeah, that means the different, we can understand the height difference between one flow. For example, this is a slope, yeah, and the water running down the slope here, and we consider in this season the relief is the height, the difference between the top and the toes, yeah, of the slope. That is the relief. So the higher, then the runoff will be larger. Yeah, and we will have a more runoff. Yeah, and the velocity will be higher, and also the surface infiltration and how the, the water come into the soil. That is a surface infiltration. And there, when there is a tree or then where there is no tree, the infiltration can be different, or the speed of flow can be different. Yeah, the vegetative cover means the tree, yeah, on the surface may play the role of for water to coming into the slope, and also it play another role as again the flows, because it's resist the flow to going down. Yeah, and also the storage of surface, that means the ability of soil and rock on the surface here to keep the water for short or long time. So we go with the surface storage, and all the factors here influence the runoffs. And we have a different type of surface flows. The first is a sheet flow. Sheet here mean it can be flow in thin layer. So imagine when the surface is flat, then the water from the rainfalls falling down on the surface, and then it run in thin layer on the surface, and it can erode the soil on the surface. Yeah, that's called erosion. Erosion can be flatly, can be evenly. Yeah, here like in this figure, the overland flow like here on the surface, and whenever for certain distance, maybe the overland flow, the sheet flow here can concentrate. When the soil and rock is soft, it can be concentrated in the channel. Yeah, then it will be the channel flows. Yeah, the second type. And here the channel flow means the water concentrates in confined channels. Yeah, so the flow along one direction. Yeah, not flat, not in the wide areas, and it can when the flow in channel, it can form the rain gullies, creek, or stream. So creek means the terrain between the stream and the river. So to the last part, it will be the river. It's caused by the flow. It's caused by the channel flows. Okay, on the right side here, you can see here we have a system of river or stream. And before coming to stream, a stream here is a channel flows, and the water come to the stream. Yeah, before become the channel flow, is a sheet flows. Yeah, the water run in sheet flows, and both sheet flow and the channel flow can cause erosion problems. And here the way of the erosion is down cutting. That means the water flow cut down the torrents. Yeah, make the stream or make the gully here. In this picture is a small stream or it's a gully. Yeah, the channel of water, and it tend to cut down to deepen this channel. Yeah, that means the vertical erosion. Yeah, we call it the vertical. And when the water widens the channel, then we have the horizontal erosion. And normally the vertical erosion occur in where the velocity of the flow is high. And in contrast, when the velocity of flow is slow, then the horizontal erosion will occur. We talk it later. And the next part here, we talk about the activities of stream. Yeah, and Three main activities upstream can be three activities. Yeah, three work. We can call it work. Yeah. The first is erosion. The second is when the soil eroded, it will be transported in the flow, and it is a activities of transportation of the sediment. Yeah, and the last, after a certain time, when the water cannot carry the particle of soil or sediment anymore, the sediment will settle down and deposition occur. So three main work: erosion, transportation, and deposition occur along the flows. Yeah. And here, different factors that can affect the erosion and deposition, and also the transportation. And the first very important factor is the velocity. Yeah, the higher velocity we normally make the river or channel cutting down. Yeah, and it depends also on the gradient. The gradient is a slope of the water surface. Yeah, when higher slope, then the erosion will be occur stronger. And it depends also the channel shape. It can be narrow shape or it can be wide shape. Yeah, then the different erosion or deposition can occur, and it depends on the roughness of the channel and also the discharge. Yeah, the discharge is the amount of water flow per unit time. Yeah, discharge normally we use a Q symbol. Yeah, the Q letter. The Q letter is the mean discharge equal to volume of water, velocity of water, velocity. And normally we use average velocity of the flow, of channel flow. Actually, I already put it here. Yeah, and multiply by A value. A value is a cross-sectional areas of the stream channel. Yeah, and higher discharge will mean higher erosion. Yeah, and it normally is proportional to the velocities. Okay, like here, the illustration, the influence of velocities. And if you see the cross section of the stream at different location, and normally at the center of the cross section, here the velocity will be stronger, higher, and it can be smaller at surrounding here. Yeah, so in this figure, that show you where the velocity is high and where the velocity is low. And when the velocity is high, erosion occur. And when velocity is low, the deposition occur. Yeah, and you can see here, like on the cross section right here, you can see at this location, yeah, on the left, sorry, on the right side, the velocity is high, then erosion occur here. Yeah, this part will be eroded. And on the left, the velocity is at this location is low, then deposition occur. So normally we have the plane, yeah, the sediment accumulated here. Yeah, and like in B, so it's the maximum, the velocity is high at the channel, and therefore there is it's equal, and therefore there is no lateral erosion. Yeah, but here at the C cross section, so then again on the left side here, the the erosion occur, and on the right side, the deposition occur. Yeah. And it is better to look at this diagram on the right side here. So we can see how or when or which work or which process or which activities of flow can occur according to the velocity and the grain size. This is the grain size of sediment. Yeah. So the larger grain size, that means the 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 less ability of transportation. Then normally deposition occur. Like here, with the stream velocity in the vertical axis and the grain size in the horizontal axis, then we can see how the different process can occur. For example, with the last grain size, and when uh, the velocity increase, yeah, then transportation occur, yeah, no deposition, right? And it can, with very high velocity, then erosion occur. And for example, we consider the point E here. So with the exact the grain size here like sand, so the sand will be deposited with the velocity less than 1 centimeter per second. But when the velocity is higher than that values, the transportation occur, and even higher to up to here, maybe somewhere like 40 meter per second, then erosion occurs. Yeah, that is very interesting to see the manner of soil or sediment can be deposited or can be transported or eroded by the flows. Okay, and this show you how the shape and the roughness of the channel can influence the flows. Yeah, for example, the semicircular shape, the flow is fast, and with the wide channel, the flow is slow. Yeah, you can easily imagine relating to the Red River, for example. Yeah, in Hanoi or in the Hanoi area, the channel of the Red River is very large, then the flow is normally slow in comparison to what happened in upstream, like for example in Laos or maybe in China. Normally the channel is narrower and the velocity is higher. Yeah. And also about the roughness, yeah, with the rough bottom, then the velocity of the flow is small. Okay, and this is to show you again the influence of the channel shape and roughness. Yeah. And now we talk about the activities of erosion, the stream erosion. The erosion means the lifting of loosely consolidated particles. So the particle at the bottom or on the surface of the channel will be lifted up. It can be lifted up by abrasion or dissolution. Yeah, abrasion means the particles scrap or rub or bump together and wear down to make the particle on the surface of the channel to lifted up, to be lifted up and flow or run along with the flows. And dissolution means the water dissolve the soluble rocks by chemical reaction. For example, the reaction of calcite with water and carbon dioxide. Then then the water will dissolve the calcite minerals. Yeah, and stronger currents lift particle more effectively. It's the nature. Yeah, that's a rule. Yeah, the higher flow, the stronger flow wind easier to lift the particle up. And the we have a two type of erosion. When the erosion occur in the horizontal direction, we have a lateral erosion. And when the erosion occur at the bottom in the vertical direction, we have a vertical erosion. Yeah. And normally vertical erosion occur when with high velocity of flows. And in contrast, the lateral erosion will occur with a low velocity of flows. And here, one very basic term is base level. Yeah, base level is the lowest elevation or level to which the stream can cut its channel. That means the down cutting wind finally access this level. Yeah, we have as a base level. Yeah, the vertical erosion, that is the final limit of the vertical erosion. And we may have a two type of base level. The ultimate base level, and normally the final erosion will occur to flat down the channel bottom to equal to the sea level like this. Yeah, finally after a long time, maybe for very long time, finally the bottom of the river or stream will be equal to sea level. Yeah, that is the ultimate base level. But we can also have the change of the base level due to the uplifting by tectonic movement. Then the sea level change relatively in comparison to the surface. Then the base level can be changed. Yeah. And we have the local or temporary base level. When we build the dam here, for example, on the stream, we may build several dams, and at any be in at the upstream of dam location, there is when water change, then the base level will be changed. Yeah, and then the limit of erosion, of vertical erosion, will be equal to the reservoir level, like this. Yeah, and it cannot be lower. Yeah, that means the new base level is created. Yeah. Or new base level was born due to the construction of the dam, and therefore the stream cannot continue to erode this section to the ultimate or to the sea level. That is a term of the base level. And here are some of the conditions that cause the change of the stream activity, like rising the base level and lowering the base level. When the base level is rise, then the deposition occurs. Yeah, but when the base level is lower, then the vertical erosion will occur. Yeah, and here to illustrate how the temporal or the local base level is created. And this is the profile without the dam. And here, when we build the dam, new base level will be here. Yeah, new. Yeah. Then, whenever the limit of the erosion occurs, then the deposition occurs. Yeah. When the limit of erosion is reached, then the deposition occurs. Yeah. Okay. And here's some of the impact of the erosion activity. This is one of the very main problems when we talking about the stream and flow and rivers. And it's also our main problem in civil engineering. It can, the lateral erosion can cause, we may lose land, we may lose infrastructure like road, or maybe here in some figure, we lost the house, and sometimes it can kill the people. It can be dangerous. And this problem is very hot now in Vietnam, especially along the two main river like in Mekong rivers and in Red River and some other rivers also. We have the same problem, and this occur very oftenly due to some of the change in the base level. For example, due to the construction of the dam upstream. Now we have a lot of dam upstream of the Red River and also the Mekong rivers, and the base level is changed, and the erosion and deposition will change. Is not naturally anymore, and it's also the cause for this problem like lateral erosion in the downstream region. Okay, the second activities is a transportation of sediment in the flow, and the transportation can occur in different manners, in different ways. We have a term, the load is now it's not the load like in when we're talking about the force. Now we're talking about the materials transported by stream. So in previous lesson, load is a force, but now in this lesson, load is a material transported by the stream. And the load can be in solution, like some iron dissolved in water, and the load can be suspension, like small particle suspended in the like particle here in this flows. It is a suspension. Then solid materials that are suspended in the stream of water, and it can be the bed load like here. When the particle is large, it cannot suspended in water, it only run at bottom. It can be rolling, it can be sliding, it can be sometimes it jump up and down. Then we call it the bed load. So different way, different motion can carry the sediment. Solution, flow solution, and suspension, and sometimes rolling, sliding. The water puts the bed load along the bottom of the river or stream. And the third activities is about the deposition. The deposition occur when the velocity decrease. So then the sediment begin to drop down or settle down. We may use a settle down. Actually, we talk about this deposition in the lesson of sedimentary rocks. And stream sediment are normally or generally well sorted. That means the particle are classified. The size of particle are classified. And stream sediments are known as alluvium, one type of sediment. We have learned this in the lesson about weathering and soil and rocks, type of soil. And the channel deposit can be bar, braided stream, or deltas. So let's see how they are. And it can be floodplain deposit. It can be natural levees or back swamps. Okay, alluvial fans, deltas. How it look like. I think it's better to see later, see them later in the figures. And here the next part we talk about the feature of the stream. Yeah, the landform, sorry, the landform that caused by the stream flows. Yeah, one of very common landform, the landform on the surface or the landscape on the surface caused by different activities. It can be due to the volcanism activities, or volcano activity. It can be due to the tectonic movement, like lift up or lower down, or by folding, or sometimes by faulting to cause the basin or upheaving. And it due to the erosion of surface water, of temporary water flows, and it's also caused by the stream flow. Here now we are talking the stream flow. Yeah, the channel flows. The channel flow also the main process to cause the landform or to create the landform. Yeah, and here different pattern, drainage pattern can create the different landform. We have a different type here: dendritic, radius, rectangular, or trellis. Yeah, this is the specific name for these characters. And we have a stream valleys. So stream valleys is the most common landform on the Earth's surface, and it's caused by the different process. It's caused by the erosion. It's caused by the deposition. And according to the shape, the valley can be narrow or can be wide. Yeah, it can be narrow or wide. And when the valley is in narrow shape, it can be V shape. Yeah, look like a V letter. And normally in valley, in narrow shape, down cutting or erosion occur. Yeah, and feature often includes rapids and waterfalls. What is a rapid and what is waterfall? I show it later. And for the wide valleys, normally occur as a downstream of the flows, and the stream is at near the base level, and downward erosion is less dominant, and normally the horizontal erosion occurs. Yeah, so maybe you can add it here, lateral and deposition occur. Yeah, mainly. Okay, and the stream energy is directed from side to side to forming a flat plane. So let's see the next figures to show later on. So this is slide to talk about the feature of narrow valleys. Yeah, we talk about rapids and waterfalls. I think it's better to see this figure. What is a waterfall and what is rapids? Yeah, both waterfall and rapid is changing in the surface, on the surface shape, and cause the water flow change the velocities. Yeah, normally for waterfall, the water falling freely. Yeah, caused only by the gravities. And for a rapid here, this is rapid. Yeah, and for rapid, the velocity or speed of flow increase, but the flow still on the surface. Yeah, we call it as rapid. And maybe in Vietnamese we have a waterfall mean thác and rapid mean gành. Yeah, that is a specific name for these two features. And these two features normally occur upstream when the stream valleys is very narrow. Yeah, usually we see it in mountainous areas. Okay, because here the erosion occur more. So this figure also show you how the waterfall is created. We have a different layer of rock here. So this is a strong rock and this is a weak rock, and normally the weaker rocks will be eroded more, and then it change the surface and finally create the waterfalls. Yeah, maybe later on the rapids here will become waterfall after time. And this is for the wide valleys. Normally we have a flat plain and meander. Yeah, what is flat plain, what is meanders? Let's see the figure here. This is a flat plain. Flat plain, that means a flat area created by the deposition. And we have some natural levee, that is a deposition along the channel. Yeah, here we have a normally the levee here, the band of soil layer higher than surrounding. Yeah, and it's caused by the floods, and before the flood there is no deposition, and during the flood the particle the sediment will be deposited here on the two sides of the floodplain, and after many floods it can be built up to higher levels. Yeah, so it sometimes it like a dike. Yeah, like levees. Yeah. Okay, and here how the bar or the bar of sediment can be deposited, yeah, along the river. And we have the point bar here at the where the river curve. Yeah, and normally on this side the river bank will be eroded, and on this side will be deposited. Yeah, this is a point bar. We call the name for this. Yeah, this is a bar along the river. It can be at the in the channel we have a bar of sediment. And here how the chain of the stream, the chain in the flows makes the river or stream change the direction, and how the oxbow lake, the type of lake is created. We may see sometime in some many plain we may see the oxbow lake like this. Okay, later I show you better picture to show about the oxbow lake, but this figure from steps from different steps from 1 to 7 is a process how the meanderings occur. Yeah, that means the change in the direction of rivers. Yeah, and what happened here, we have the both erosion and deposition, and the erosion in lateral direction, in horizontal direction. And here at beginning the river is in this direction, and then it eroded it in this part, in these two parts it eroded, and in the yellow color here is a deposition, yeah, occur. And this is to show you where the erosion, this bank on the right side here is eroded bank, and this is a deposited bank, yeah, the river bank. And after certain time, after long time, the river can change the direction, and maybe at a certain time the river cut through this and run in this direction, and we left the this is the oxbow lake. Yeah, so actually it's a dead river. The flow can the flow will be not continue here. Yeah, only the water come from river bank to the lake. Yeah, but the flow in this direction. Yeah, no more the water from upstream, and we call the oxbolex. Yeah, that's the way how the metering occur and how the oxbolex is created. And we may have some example very close to us. Yeah, like here the picture I took on airplane in after takeoff. Uh, After takeoff, yeah, after takeoff, that after takeoff in Nội Bài airport, and I took this photo, and this photo is a Calo rivers, yeah, in Sóc areas. Yeah, you can see the river change the direction dramatically. Yeah, and here we have some obelisk, 1, 2 obelisk. Yeah, maybe some other but not very clear, but here we have this one obelisk, 2 obelisk very clearly. Yeah, actually before in the past is used to be the rivers. Yeah, but now it's only a lake. Yeah, but and the lake in the oxbow shape, then we call it the oxbow lake. Yeah, and another interesting map here, you can see the map of Hanoi on the right side. Right, very interesting. Here the in this part here we have a Hoàn Kiếm Lake is somewhere around here. We have a here West Lake, Hồ Tây. Yeah, this is the way to the Nội Bài airport, Nhật Tân Bridge, and this is Thăng Long Bridge, and we have a Trương Dương Bridge here. Yeah, Long Biên and Trương Dương Bridge here. And this photo was taken long time ago, before Thanh Trì and other bridge, Vĩnh Tuy Bridge, and then therefore there is no bridge of Thanh Trì. We have only we have also no Nhật Tân Bridge. Sorry, yeah, Nhật Tân Bridge is somewhere around here, should be somewhere around here, but actually this picture take long time ago. And you can see here the changing of the Red River direction. Yeah, in different steps. Before in the past it can run in this direction. Yeah, and then second time, and then finally now in this direction. Yeah, this way. And at the in Thanh Trì area we see the different process. First the river run in this direction, and then the river change because the erosion on the in this direction to the east, yeah, occur continuously, and then the channel or the river change the direction to this current location. Okay, that to show you, imagine how the river process occur in the past. And some now we can see, observe on the map some size, yeah, some features that we can imagine how it will occur. I think it's very interesting example for you to understand the behavior or process of rivers. And here one other feature of the from the process of river, maybe we sometimes we have a alluvial fan. When the small channel accept the wide area, and then the sediment come out here, the velocity decrease immediately. Yeah, suddenly then the material settle down at the toe of the slope here. Then we have the alluvial fans. Yeah, this is the cartoon to illustrate how it occurs. Yeah, and this is the rain pictures. And here how the braided stream normally occur in the downstream. Yeah, when the water near the sea. You can see on this picture, this is a rain case. Yeah, the flow divided into different channel. Yeah, this is a braided stream. We may find it somewhere in some river, even in Vietnam. And here the formation of the delta like Red River Delta or Mekong Delta or some other river delta, the way that different layer of soil deposited, yeah, here on the 3D three-dimensional space, and here on the cross section, yeah, in two-dimensional. And on the left, on the right side picture here, you see the picture from airplane to show you how the Red River Delta, yeah, you can see here the different braided stream coming to the sea and bring the sediment in the yellow color here, and the sediment will be accumulated or deposited, will be deposited here, and it will be widen the deltas. Yeah, the delta will by time the delta will expand to the sea. Yeah, and normally it can be different part, top set or foreset or at bottom set. Yeah, and normally at the bottom set here, because it's far from the source, then the material is here is very small particles, and this part is larger, and that be quartzite or lattice particles. And normally to the sea, the particle of soil and rock already very small. Normally we have a sand and clay and sin. We rarely see the coarse material like coarse sand or gravels. Yeah, mostly from sin and clays. Okay, and some other picture about the delta from other rivers, famous river in the world. I think it's not necessary. And here talking about the chain from upstream to downstream along the rivers. Yeah, we may see it's better to see this slide. Yeah, this slide is already brief description, and this slide brings you more clear, more detailed description. Yeah, so about the stream profile along the river here, normally it curves slightly like this, and at different part, the different process occur, different material will be accumulated or deposited. Yeah, for example, like in the upper part, normally the valley is narrow in V shape. Yeah, and vertical erosion occur. And it cutting down the bottom of the stream. And due to the uprising and attrition dominant process, yeah, and yeah, traction and sanitation at high flow. That means the particle run at bottom mainly, yeah, not in suspended state or not in other manner. Normally by traction and sanitation. That means particle, the sediment with cause particle jump down at the bottom. Yeah, and lot size is flat and angular. Yeah, not only the size, the shape, and not only the size, but also the shape can be seen. Yeah, normally the boulder here upstream have a large size and angular, not rounded. Yeah. Okay. Similarly, we have at the middle ridge and lower ridge at the part where the river access or near the sea, yeah, or ocean. Yeah, here. Like for example, we have the Red River along here. Maybe we may consider the part in China is the upper valleys. Yeah, and from China boundary between Vietnam and China, for example, from Lào Cai to Việt Trì, to Phú Thọ is a middle ridge, and from Việt Trì down to the sea, we can consider it's a lower ridge. Yeah, so at different location we may see different material, different process. Yeah, like in Hanoi area, mainly the deposition occurs. Yeah, and maybe the lateral erosion occurs, can cause a change of the channel, the direction of the rivers. Okay, you can go for detail later with these pictures. I think it's very summaries. Yeah, it's a summary for the many what we have talked in previous slide. Okay, this part about the flood and flood controls. One of other problem relating to the flows is the flooding. Yeah. So normally after heavy long rainfall, we have a flood. It can occur in mountainous area. It can occur in plain areas, and normally it's very destructive. And we can consider flood is a geologic hazard. Yeah. And the cause of flooding, it can be nature, from nature. We call it naturally occurring. And it can be due to the human activities. Flood can be caused by, sometimes it's caused by the, like for example, like when we build a dam and water flow over the dam can cause a flood. Yeah, or when the dam is broken and the water run downstream and can also cause a flood. And all of these we call the human induced. Yeah. It can be direct or it can be indirect by the human activities. And we have a different types of floods, like regional floods, flash flood, ice jam flood. It's not normal. It's not occur in Vietnam, but in general, we have may have an ice jam flood, and we have a dam failure flood. Yeah, dam failure floods. Okay, so here some pictures show you the influence of the flood. Yeah, the first picture on the left here is a flood, and in the flood flows there is a material, many sediment inside, maybe sometimes with very large particles like powder, gravel, and here you can see the mud inside. Yeah, and if the flood carries the particles, especially the large particle like powders and gravels, it can be very dangerous to the on the way it go through. Can very destructive, can damage the structure, can kill the people. And here the flood occur in the floodplain. It can be submerge the house, buildings, and road, and influence the lives of the people. And the flood is actually the main problem that our university, the main topic of our university, and therefore maybe from beginning one of the reason to establish the University of Thủy Lợi, because one of the major tasks of our study is to mitigate the influence of the floods. By we have a different flood control measure. It can be engineering or it can be non-net structure measure. Engineering or structure measure, like we can build up the levees like dike, river dikes. I think it can be river dike. So that's a dike made by the human. Then we call it the artificial levee. Like we have in Red River, we have the system of dike along the river to protect the people from the flood. We may use the dam by building the dam, not only to use to utilize the water, but also to protect or to control the water flow downstream, especially during the flood. Yeah, and of course we need to manage good, manage well. Then if the dam were built with the and use with the management, good management, then the dam will control the flood well. And sometimes we can use a channelization that change, the people can change the direction of the flows, and then to mitigate the influence of the flow. And we have some other, many other approach to protect the people from the flood. Yeah, and some other approach with no structure, that means non-structural approach, like we identify the risk areas. That means we need to determine where should be flooded, where can be flooded during the or after rainfall, and then we evacuate the people from that location. Yeah, for example, I remember long time ago when I was a child, one part of Hanoi in Phúc Xá, the area outside the dike, Hanoi Red River dike. Normally every year the people at the location need to move to move out of their house because of flooding. But now it's all flooding not anymore, because we have a lot of dam upstream. Yeah, then the flood already controlled. And we may have a zoning regulation for development. Maybe we should avoid to develop in the flooding area. The low surface location should be avoided. It's very important. And normally for planning any project, or for example planning for new urban, for new city, we should consider the zone of flooding. Yeah. Okay, and here talking about the flood control by using dam, we can store the water for slow release. Yeah, lower crest of flood spread out over time. Yeah, because after raining without dam, the water running directly from upstream downstream, and many water. But with dam, part of water, yeah, can be stored, and then later on we, after rain, we let it flow down gradually. Yeah, so it will reduce the flooding downstream of the dam. And the dam have many other function. Yeah, for irrigation, agriculture, maybe for hydroelectricity. Yeah, and some other function. Yeah, reservoir carve previous land use, so it can fertilize the farmland and change the maybe we have the nice landscape. Yeah, it's not important. I think the main function of the dam for flood control is here. Yeah, and here the other function is we may not need to consider about that. For example, the for fish mitigation is not for flooding control, it's for other purpose. Yeah. Okay, here's some of the picture about the dike, yeah, the levees, yeah, and about the dam. Yeah, I think this picture is for Red River, and this is a Hòa Bình hydropower dam, yeah, very famous for you. And the other method is channelization. That means altering the stream channels. Yeah, maybe we dig the channel to make the flow in the direction we want, to avoid the channel in the natural direction, because in the natural direction it can cause the impact to the people. Yeah, and by clearing the channels, by directing or widening or deepen the channel, a different way to change the channels. And we may have a artificial cut off, yeah, like strengthening the channel. What is the artificial cut off here? I think it should be here. For this case, before in the history, the water flow in this direction, yeah, and it changed gradually by time, and finally people build the dike here. That is a cut up. Yeah, this is a artificial cut up because the dike here built by the human, yeah, long time ago, and now the river must go in this direction. That is a way to mitigate the flood for these areas. Yeah. Okay, I think that is already the last. Maybe we have some explanation about the artificial levees or dike, right? Yeah, and that is the last slide of this lesson. I think it's already enough for the lesson about the stream process.